chess. We are going to see with this pic. Okay, I will give next
Moganapriya, your voice is not continuously audible. First, while you're speaking, it was good, ma. In the same location, you start speaking. Yeah. Mm. What happened? Only 73 students. What about others who are from electives, ma? I told you, still you people, ma'am will finish by 40 minutes and you are 20 minutes, you have the time. Still now you are not joining. I don't know why. Every time I have to give the instructions. Muttamil Shelvi, any problem? Only, I think Muttamil Shelvi only, yeah. No, no.
Ma'am, at the end I will take, ma'am.
Okay, Moganapriya, what happened? Or else
Ma'am.
Moganapriya, any network issue, ma? Or else I will start my class. You people will take at the end.
Ma'am.
Tell me, Moganapriya.
Ma'am. Ma'am, just 1 minute only, ma'am. 1 minute only, ma'am.
Yeah, yeah. Mm.
Good morning,
Directly.
guys.
Yeah, yeah. Continue, ma.
Can anyone guess the topic which we are going to see with this pic? I will give another clue. Can anyone guess? Okay. Next slide will be the answer for that. The first picture is infrared. The next is television, and the next is remote. Then next is
Muttamil Shelvi. Sorry, Moganapriya.
you, and the
Your
girl is
voice.
singing. So you sing. That is the pic. Next pic. Next micro controller. So the topic we are going to see is infrared.
Moganapriya. Your voice is not audible, Moganapriya. I think you stop.
Ma'am?
Your voice is not audible. Directly go into the topic, ma.
Yes, ma'am.
Actually, still your voice is not audible.
Network.
Okay, then you do. Tomorrow you try
The
to
network
resolve
problem.
it.
Okay, ma'am.
Yeah. You stop sharing.
Okay, ma'am.
Now it is
Okay.
okay. I don't know why. Moganapriya, I don't know why. Is there any network issue? You try it, resolve it, and tomorrow you take the class. Are you clear, ma?
Yes, ma'am.
Okay. See, only 5 minutes of time for you to tell the applications. Yeah, because we are supposed to cover the syllabus. Don't so my advice is take 5 minutes, only 5 minutes for you to present your applications. Okay. Now now can you able to view this, ma?
Yes, ma'am.
Yeah, not my mail. Actually, this. Kindly listen to this video, ma. Yeah, I'll start from here. Yes. Yeah. So now you people can understand the purpose of RS 232. So they were saying now the most of RS-232 have been replaced by Ethernet and USB cable. Now we have a USB cable to connect a computer with printer or and all. And if I want to connect any communication, I didn't need any DCE equipment and all. Directly I will connect through Ethernet or LAN cable. So that is the thing we have seen about that. So yesterday class, while we are starting, we were focusing on distributed embedded system and embedded networking, and RS recommended standard cables. Two cables we already discussed. So why still RS-232 is popular now? Due to the cost is inexpensive, and we all know it can be used only for 50 feet maximum. They said that that particular video described even if we go for a 100 feet, the voltage loop problem will exist. And one more thing, the data speed will be 20 kilobytes per second. But when I go for RS-485, what is the difference between RS-232 and RS-485, ma? Anyone tell the difference? Anyone tell the difference? RS-232 and RS-485? I have already mentioned only.
Half duplex, full duplex, ma'am,
Super.
and cable length is different, ma'am.
Yeah, very good, mom. Aruna Devi. RS-232 is full duplex. RS-4585 is half duplex. And RS-235, RS-232 is only for 50 feet. And this is about 4,000 feet. And here the data will be 20 kilobit per second. But RS-485, 100 kilobit per second. This is the major three difference between RS-232 and RS-485. So you have seen that how they were connecting RS-485. Okay, so by connecting the Ethernet LAN, and from that they use RS-485. We all know due to the inexpensive as well as the olden days how they connected now. So most of the industries they are using RS-485. But now we were using LAN, Ethernet as well as USB port only. Okay, so now actually we completed 4 topics in the 4th unit, ma. And actually, have you seen distributed embedded over, embedded networking over, RS-232, RS-485 is over. So today we will see this CAN. Actually, in this unit, the questions are very simple. You can expect from any serial protocol, the one question will becomes whether it may be RS-232 or RS-485 or I2C, inter-integrated circuits, serial peripheral interface, USB, universal serial bus, CAN, Ethernet. So sometimes they will ask you to explain or write a short notes on one. So you always have to prepare each serial protocol as a 16 mark question. So definitely they will ask any one serial protocol. That is the thing. So RS-232, RS-485, you combinedly study as a 116 mark. Okay, and next we will enter into the one important area is CAN, control area network. I think directly I will move on to that slide. See, it's a very very important question. Controller area network is very very important. Actually, see this difference which is told by Aruna Devi. Oh my god. Yeah, see, single simple full duplex, half duplex, 50 feet, 4,000 feet, 220 kilobit per second, and 10, not 10, I think so, 100 kilobit per second, 100 kilobit per second, 20 kilobit per second, and 100 kilobit per second. Okay, so that is the three important difference between the RS-232 and RS-445. And one more thing, it is maximum. We have required 32 driver and 32 receiver for RS-445, 485, because it is a simplex, half duplex. But for RS-232, we need only one driver and one receiver. Okay, now we will directly enter into CAN. See, students, listen, ma. It's one of the very very important. I think. Wait, how many participants? 74 are there. Where others went, I don't know. I will enable the waiting room. Okay. Okay. So students listen ma, can na controller area network. Remember, study this as a 16 mark question. Controller area network. Okay, so you have to understand that the controller area network, what is the thing is, it's mainly used in automobile industry. This is also one of the serial protocol. Okay, so you have to understand, uh, just imagine our human body. Okay, in the human body we have a nerve system that is equivalent to controller area network, and we have a connection with our parts of the body. Similarly, here we used to say nodes. We used to say electronic control units. So the electronic control unit is enabled the communication by controller area network. Okay, so electronic control units, I told you, CAN is very very popular in automobile industry. Now the automobile industry is becoming very booming in technology, and we were seeing so many cars with so many features. So while moving from higher end, I told you it's not like a olden car. We have a automated key, everything, we have a secured version. So it's just while sitting in a car we are thinking it's like an computerized system we have. So all this communication, everything is developed in the automobile industry through this controller area network. So I told you controller area network is nothing but a nerve system. It's like a, it only carries the information. So here when you see ECU means, I told you, electronic control unit. In that you have seen that when you take a car, airbag will be there, automatic ABS anti braking system will be there. Okay, and you have in dashboard also you have some control, automatic car parking, reverse sensor. So each and every unit is nearly some they are saying the 70 ECU unit will be available in the today's modern car. Okay, now you see, in CAN we have only two wire. One is CAN low, another one is CAN high. Okay, so here you see ECU1. ECU1 means, I told you, electronic control unit. So in any modern car, more than 70 ECU unit we have separately. Okay, so here what this particular thing is, first ECU1, look up on this. Mm. First ECU1. In the first ECU1, it will prepare and send. Okay. And the next ECU2, it will receive. And this ECU3 will ignore. Can you understand or not? So each and every unit, according to their work, one will send, another will receive, and another will ignore. Okay. So send means, you have seen that can low, that is this orange color wire is enabled. Receiving, can is high. Okay, here it doesn't transmit as well as it doesn't receive, so they put it as a cross mark. Are you clear? So if I want to send any signal, that is sent through can low. If I am receiving any signal, I am receiving through can high. And if I am not getting any signal, I didn't communicate with the can bus. Okay, and you all know one of our alumni got placed in Robert Bosch. I think while you are attending our conference and all, our alumni had speak that Robert Bosch have developed this CAN bus in 1983. So you have to say you have some dream level of companies, not only in software. It is available in our core company also. So you have to be strong in our area. That's it. Okay. So they started the canvas at in 1983 by Robert Bosch, and the protocol is officially released by Society of Automotive Engineers. You all understand that all protocols has to be approved by all. So even I told you, while RS 232 cable, EIA, EIA means Electronic Industry Automation only, they released RS. So similarly, this canvas is also started, and this is also released by this engineers. And then slowly the canvas controller is developed using Intel and Flips. I think you can able to see this. This canvas is introduced by Intel, and shortly thereafter by Flips. So the first, the CAN controller is developed by Robert Bush. Okay. So now you have seen that. So the CAN has an communication between each and every electronic communicating wire. So it has an a data with that. So can has two wires only. One is can low and another one is can high. So this data will be accepted by ECU. ECU means electronic control unit. So for each and everything we have a separate ECU. Now the next one, you all understand this figure, before can, after can. So before can, you have seen engine control, where my engine control should be there na, transmissions will be a active suspension will be there, dashboard connection. So there will be no linking on the bus. So if I want to took the air conditioning, I have to close my power window. So there is always linking between that. So to communicate, I want to communicate to any one of my communication, I have to send to that particular communication, I have to verify it. But after can comes, what happened now? The entire system is controlled. Okay. So we have already we have told, I told you, we have two kind of bus, can high, can low. Okay. Now according to the speed also they are classifying. High speed bus, low speed bus. Actually, what is high speed? What is low speed? Now, you all know. When I am looking my thing, I'm having some controller over engine, anti-lock brakes, transmission control, active suspension. So these are the very important in driving the car. Okay, or driving any automobile. So this all comes under high speed. So whenever any accident or and all, automatically the system has to be simulate accordingly, or else if any traffic comes we have to put the brake, everything, the engine is working in high speed. So my cans bus also be activated in high speed. So that's why these are all connected with high speed can bus. And when you look up with lightning, air conditioning, power lock, power seats, power bags, power windows, and airbag. Even though you may ask, ma'am, airbag is also in the emergency condition. But while we are seeing that any crash in engine, that will only activate this airbag. Okay, so these are all connected with the low speed. So after can, the entire electronic control unit have a communication protocol. While I told you that in any system is there, if the particular system only having the data, the networking is not possible, sharing is not possible. So if I want to share or if I want to interconnect everything, always the protocol, the serial communication protocol plays an important role. If I'm going into the ATM, if I'm drafting any if I'm getting any amount, what happened, definitely it has to be a communication model. So yesterday itself they have explained with the GSM module and all. So if I want to go with some uh, my with my position, GPS also been take place. So the same thing is here. So each and everything, the protocol, the cans protocol will be activated here. So we have a can low speed, can high speed, where can high speed is related with the engine control, can low speed is activated with the dashboard control inside that. Okay, inside the automobile or inside a car. We all know now we are moving only with this kind of car. So we cannot, when you go with higher end of car, you can see so many features. The so many features is nothing but they are adding more ECU, electronic control unit, inside the car. And through the electronic control unit only they are having. Actually yesterday I have seen one advertisement in that the MG announced one car, we have a automated parking sensor. So what happened now, if I press that automated parking sensor, I need not to drive my car. Automatically my car will be automatically find out the space, and it automatically parked over the particular space. And you all know now we have an automated car itself. So what happened now, when I'm get into any mall, it will go to the parking lot, and in the parking yard it will find out the space, and it will park by themselves. And once I want to get the car, and the car will be started from that place, it is only in the higher end. So the higher end is nothing but they are adding more ECU, they are connecting the can controller, the communication is happening, and it is finding the more length, breadth, everything, whether car can able to accompany at that particular space and all. So we need not to check left, right, that mirror, this mirror and all, not needed now. So once nowadays the car driving is also become easiest one comparatively. Okay, so olden days we have a hand gear and all to driving that car. Now we have everything has become easier. So you see, my red color wire indicates the can. Okay, you have seen anti braking system, air conditioner, suspension, instrument panel. And you all know, whether even you didn't put your seat belt, some of the car can, cannot able to ignite the engine. So that much of control we have. Okay, transmission, engine control will be there. So this is entire thing I have explained with one image, that's it. And now I told you very much, the can is popular in automobile industry. But while we are go with some of the applications of can, uh, passenger cars, trucks, vehicles, cargo trains, maritime electronics. Okay, so in ships and all, aircraft, factory automation, industrial machine control, lift also they are using lift and escalators, building automation, some of the medical equipment devices. Okay, some non-industrial control and non-industrial equipments. Okay, and this is some of the advantages of can. Okay, and you all know, comparatively simple and low cost. I can fully centralize to my can. Extremely it is easy to easy, robust. Okay, so efficient. Okay, because there will be a top priority go to get the data, access the bus without interrupting the other ECU. So nowadays I told you the can is standard in automotive industry. So automobile industry, the can plays a vital role. Okay, so the future of can, what is the future of can? We advanced everything, but they told the cloud computing, the data can be stored in the clouds. And we have a IoT devices. I yesterday told you one example. One of our students have taken healthcare. So I told you, ambulances also, what happened now, automatically the particular message will be sent to the hospital. There they will identify their location. And what happened immediately, the ambulance will come to the victim place, and then they take over the patients. And then that will be along, traffic light also will be controlled. Wherever ambulance comes, automatically the traffic light will open. So this much of control will be there. One accidents will take place now, we need not to wait till until, and otherwise if other person is spotting out. So we can all have a IoT related control. So when the particular person have hit, automatically it will send the message to their relative and all. And then it will be intimated to the nearby hospitals. So through that, the person can be saved. Okay, so they are saying that IoT connected vehicles also available, autonomous vehicles will be there. Okay, then vehicle telematics, IoT can loggers will be there. But while we are bringing this new protocol, we can, a future can bus also can be implemented in the vehicle. Okay, now we have seen some introduction about the can. Now we will go for can implementation. Can implementation, we have a three kind of can: standalone can, integrated can controller, single chip can controller. Okay, uh, standalone can controller, integrated single chip can controller. So now you people kindly see this standalone can controller. Standalone can controller means, you have seen, these are the three main parts of can controller. So what are the three main parts now? Can transceiver means it can do transmission as well as reception, that is can transceiver. Then can controller, so definitely a can controller will be there. Okay, then the microcontroller, I told you, for each and everything there will be a separate microcontroller will be there, DSP controller will be there to control. So can is the protocol to communicate between this. So we have a two kind of bus: can high, can low. Okay, so that will communicate with the can transceiver. So can transceiver will do both transmission and reception. That's why receiving, transmission. So we all know transmission and receiving, definitely the control and status line is also plays an important role. So to that we have a control and status line. Then can protocols. So I told we have a messages for CAN. Okay, so we have a separate data framework. I'm starting because it is a communication. We all know RS-232 is doing UART communication. Means how will you identify? It have one start bit, it end with one stop bit. In between that, data bit will be there, then parity bit will be there. This is the range for UART for RS cable. But when I go with the CAN controller, while I'm designing my CAN protocols, it have a separate protocol. Not It's not following any UART or USART. It have a start frame, end frame, and then redundancy check frame, acknowledgement frame. All the frame it have. I am having disturbance. Okay, so these are all a CAN controller. Then message filter, message buffer, CPU interface, everything will be in the CAN controller. And this is my microcontroller. We all know definitely microcontroller will be there. Means it's a high layer protocol because all my control will be in this microcontroller, and mainly it is a application layer. Because if I want to put my seat belt, definitely I have a separate ECU unit there, so that will be accompanied with the this microcontroller. This is a high layer protocol. So this is for transceiving and receiving. This is the CAN message frame will be formed in the CAN controller, and this is the microcontroller part. Okay, now you may ask, ma'am, what is the difference between standalone, integrated, single chip? Only thing is, standalone means all these three will be present separately. Transceiver separate, CAN control separate, microcontroller separate. But when I go with integrated CAN control, what does this means here you have seen this figure. CAN transceiver separately, CAN controller and microcontroller will be embedded on a single chip. You have seen that the development have begins, the size of the unit will becomes very less. The next one is single chip CAN controller. What is the difference between the single chip? Now all this CAN transceiver, CAN controller, microcontroller, all will present in a single chip. So that is nothing but a single chip CAN controller. You have to understand that what is the difference between standalone, integrated, single chip. So you have to understand these three are separated, that is standalone. Yeah, okay. If CAN controller and microcontroller is fabricated on a single chip, it is a integrated CAN controller. If all three are fabricated on a single chip, it is called as a single chip CAN controller. That is the thing, that there is more not more much difference on the CAN controller. Okay, if everything is diffused in a single chip, that is a single chip CAN controller. Okay, now this is the CAN controller architecture. I told you CAN controller means we have a separate framing. Like I have to identify the acknowledgement bit, I have to detect my error, I have to detect the signal, I have to synchronize that. Okay, so all this will be available in the CAN controller. So we are going to see that separately. Apart from that, we have a transmit message buffer, receiver message buffer will be there. CPU is nothing but your microcontroller. Okay, we all know CPU is our microcontroller. So microcontroller or any DSP controller can be used. Okay, so this is your CAN control architecture, CAN controller part, and then this is your microcontroller part, and this is your status and control, like that is transmission and receiving buffer will be take place. But you all understand this entire part is our microcontroller part. Okay, and I told you CAN controller means this all fields are very very important field. Start of the frame, arbitration field, that will decides which has to be that. For example, if I want to put the seat belt, my engine has to start now. It always wait for the seat belt, then only the engine will be start. Or else if I am closing the power windows, or else I can't, I have to close all my windows, so that it will check. So while I'm checking my air conditioning, my power windows has to be raised. So everything, the arbitration field will go for always judgment. That is the actual meaning for arbitration. Here also the arbitration is nothing but judgment. After that only it will work. Okay, then control field, data field, CRC, cycle redundancy check field, then acknowledgement bit, end of the frame. So this is my message frame. Okay. Actually, I will take till 10 15 ma. Actually, today you have why all peoples are going into. You have a kagot quiz at the end ma. Can you understand? Because today it's a Wednesday, so I will conduct kagot quiz only from RS 232 and RS 485. 10 questions only ma, 30 seconds only. Okay. Now can implementation. We have a two types of can. Basic can, full scan. Okay. What you may ask, we have a can high, can low. Okay, high speed CAN bus, low speed CAN bus, and then we have seen with the single chip CAN controller,
Ma'am,
standalone. Yama, yeah, tell me.
ma'am, Koteswari told me to join her, ma'am, in class. She is in waiting room, I think.
I'm every time
Ma'am,
enabling
her
the.
network went, ma'am.
Actually, she's not in the waiting room. Ma.
It's
I think
time to
Kodishwari
Okay.
got
She
joined.
came, ma'am. She came, ma'am.
Yeah. So full scan versus basic can. You all understand? Full can, basic can. What is the difference? Full can will be used in power trains. You now we have all metro trains and all you have seen. Okay, and basic can is only for car body. Okay, so you all understand the lengthwise and the application wise, the powertrain having a more controller than the single car. So this is basic can controller, and this is having full can controller. Okay, so here you will see one or two transmitter receiver buffer only here, but here you can see 16 message buffer will be there. Okay, so while you are having some 10 to 20 compartments will be there, the entire train, we all have a bullet train will be there, automated train will be there, metro train will be there and all. So we all have that kind of train also. They are using can controller, so there is a communication is happening now. They have you to use 16 message buffer registers will be there, but here we are having only one or two transmission. And one more thing is here, while you are seeing here full can controller is more cost, but basic can controller is less cost. Okay, here the bits per second will be um, less, but here the bits per second will be very high comparing to the basic controller. I think I will show you one more important diagram is between basic can and full can. This is the difference. I think you can see this is my powertrain and this is my car body. Have you seen car body? What are the things they have taken? Steering, radio, climate, door, sunroof, airbag, and you all know now the higher end version of car, you have a sunroof. So sunroof will be automatically opened. So, but because of there also we have a control. Airbag and door, driver seat, rear lights, radio. These are all in car body. When you go with engine, powertrain, you have seen that ABS throttle valve. That is very important. Transmission and central module will be there. So this is nothing but a full can controller, and this is nothing but a basic can controller. Okay, and here I can go greater than 250 kilobit per second, and here I can go greater than 125 kilobit per second. Okay, so you have two types depending upon the application in can. One is basic can controller and another one is full can controller. Okay, now can frame. I told you can is not using the frame of UART or USART. It have a separate frame, separate protocol for mainly for this. So if I want to do any communication, I am having a standard can frame structure. You just see, this is my data. 0 to 64 bits will be allocated for my data. So it is transmitting 64 bits now. The remaining bits only for the control. You just see SOF, start of the frame, and EOF, end of the frame. So you always understand You remember UART, universal asynchronous receiver and transmitter. Also we have a start of frame and end of frame will be there. Okay, then this is a standard identifier. Okay, and you all know the another bit, RTR, remote transmission request. Okay, we all have so many ECUs, so I have to want to do any access, I have a remote transmission request, then control bit is over there. Then while I'm coming for here, cycle redundancy check, it will do all kind of parity check, sum check, signaling check, all will done through this. Any error that will be, so nearly 16 bits they allocated for this. So understand this, this diagram is very very important. If they are asking any 16 mark question, you have to write what is standard can frame structure. So start of the frame is important, end of the frame is important, and identifier and RTR control. And this is for cycle redundancy check and acknowledgement. In between I am allocated nearly 64 bits that will carry the data. Okay, so you all know can logger. Can logger means, as mentioned, two can fields are important for can logging. That is can logger. Can logger means I can record. Nowadays in car also we can we have a recording the data. So can logger will be there. We have some SD card inside the car, so that will be automatically recorded there. Sometime we can record it in our own PC, because nowadays we have a communication. Okay, so can interface will be there. Through that I can record my data in a PC. So even through that, car hacking also happening. Now you can see we have a automated, so without driver also we can operate the car. So if I can cack your car, automatically what happen, if it is automated, the car will be driven from there and it will be automatically we have a car hacking. And you have seen some of the movies, they were using this kind of systems. Okay, so can bus data, I can have my data in can logger. The logger, through that I can load my data in SD card. Okay, or else I can interface with PC to get the data. Okay, I think we have only less time. So what we do, I think Mogna Priya, sorry you have prepared well, but next tomorrow you will take the class. Now Muttamil Chelvi and Nandini, we will check it. Muttamil Chelvi,
Yes, ma'am.
yeah, you start sharing. And one more,
Okay,
tomorrow,
ma'am.
Avinash, Avinash, Avinash is here. Avinash,
Ma'am.
Avinash.
Yes, ma'am.
Tomorrow you have to take Avinash. Is
Okay,
clear?
ma'am.
Balashankar,
Yes, ma'am.
you have to also take. Okay, only 3 slides enough. 5 minutes. Okay, Bharati, Bharati, are you there? Okay,
Bharat,
Muttamil.
ma'am.
Sorry, Bharat.
Ma'am, can
Sorry.
I start, ma'am?
Yeah, yeah. Start. One more time, Muttamil Chelvi. Bhavana,
Yes, ma'am.
Bhavana. Tomorrow you have to take Bhavani, Bhavani. Okay. Still we will keep till Bhavana. Okay. Till Bhavana. Yeah, yeah, Muttamil Chelvi.
Okay, ma'am. Good morning to all. I am going to take one of the application of microcontroller. I am going to discuss about electronic clock using PIC microcontroller.
Louder, louder, Muttamil
The
Chelvi.
diagram consists of PIC microcontroller. The components of electronic lock consists of a PIC 16FA77A controller and LCD 4x3 keypad and a crystal oscillator. PIC microcontroller is the main part of the electronic lock, and LCD it displays the status of password of secured system. The keypad consists of 12 push buttons and The crystal oscillator is 8 megahertz crystal oscillator. First of all, okay, the electronic clock takes input from the user with the help of 4x3 keypad. Mm. The PIC microcontroller reads the input and compared it with already stored password. The default password 1234 is stored in EEPROM of PIC microcontroller. Next slide, ma'am. After taking input from the user, the inputs are stored in array. After that, microcontroller compares the array values with already stored value of default password 1234. If both the values are equal, microcontroller opens the electronic log. LCD is used to display the status of a protected secure system. If user input password is equal to EEPROM, the status access has been granted, displayed on LCD. Instead of LCD, we can also use light emitting diode to display the status of electronic clock. That's all, ma'am.
That's all. Yeah, you go to the previous slide, ma. Yeah, she had taken electronic lock. So you people understand, by searching this kind of applications, she had taken one thing electron. Now you have seen in many of the thing we have an electronic locker, not like olden days we have a lock, we need a key and all. We don't have a, such a system. So if you remember that this electronic lock, where you can use, ma, you can use it in the locker, and even in the doors also you can see that many of the outdoors they don't have a key system, they have a locking number only. So by using that particular lock only, the particular door will open. So I think she had taken a wonderful applications. Very good, Mutamal Chelvi. Yeah, you
Thank
stop.
you, ma'am.
Yeah, stop sharing, mom. Yeah, next Nandini.
Yes, ma'am.
Yeah, you can share.
Abhirami will be share the screen, ma'am.
Abhirami, you take. Now Abhirami become very popular on sharing the screens and all. Good.
Shall we start, ma'am?
Yeah, start, ma.
Good morning, everyone. I am going to tell about the auto irrigation system using soil moisture sensor and PIC microcontroller.
Nandini, somewhat louder, ma.
Okay, ma'am. It mainly develops to the plant of auto irrigation system to measure the moisturizing of the soil and automatically turns on and turn off the water supply system. Their components are PIC, soil moisture sensor, LCD, relay, LED, motor. We are all know about the PIC microcontroller. It is a 8-bit microcontroller. Its main function is to read the values from the soil moisture sensor and displaying the messages to the LCD and controlling the relay of the motor. Then soil moisture sensor module. It is used to measure the volumetric water content of the soil. It consists of two prongs which may be inserted in the soil. Depending on the quality of the sensor, we can be inserted to the roots of the plant. It can be act as a comparator and a pot to change the sensitivity of the sensor. Next slide. Here the LCD is used to display the key messages. It is connected to the port B. These control pins of the LCD are connected to the port C. One terminal of the relay is connected to the motor. Then other end of the relay is connected to the collector of the relay. The relay contact is given to the AC supply and motor. LED is connected between the DC supply and closed when the motor is running only. Here the main function is used to measure the conductivity of the soil from the soil moisture sensor. Then the soil moisture sensor has the comparator to compare the voltage from the prongs and predefined voltage. Then the comparator is high, only the soil condition is dry. This output is coming from the soil moisture sensor in given to the analog input pin. It can be continuously monitored by the PIC microcontroller. The LED, when the transistor is turned on, the relay coil gets energized and turns on the motor. The LED is also used to glow and act as an indicator. When the moisture of the soil is reached the threshold value, the output of the soil moisture sensor is low and the motor is turned off. Its main reason is to used to sensing the moisture of the soil to send the water supply system to the plant. Thank you.
Yeah, go to the previous slide, ma. Yeah. Soil moisture sensor. I think now the irrigation field she have taken. Very good, ma. Very good, Nandini. And
Thank you, ma'am.
she have explained with that. So I think by seeing this, you can understand where the microcontroller is used. I have allotted 96 students has to take the applications now. When you go with any one of your automobile car, you have a 70 ECUs. Electronic control units will be there, so each one take one application, they can explain how it is working and all. So I think this will help you for writing the assignments also. So don't let till I have to allocate the topic for you. So kindly prepare maximum of 3 slides, okay, and check whether your network connectivity is stable. You people kindly take the seminar. Yes ka? Yes, stop sharing, ma. Yeah. And one more thing, please students don't go anywhere. I will give you the kagot pin for you, okay. And meanwhile I will take the attendance also. I think you can able to see the kagot pin, ma. Oh my god, sorry.
Yes, ma'am.
Yeah, kindly please attend to that, then I will take the attendance and I will mention who are all absent. Anyone check whether it is working good? Only 10 questions, ma. See, I will read out the names who are all absent. Is it working, ma? See, register number 4, Ajit Kumar. Register number 5, Akash Singh. Register number 9, Anurag. Anurag is absent. Okay. And then I don't know Amrita Harshavardhan, why he's come in 2 names, I don't know. 16.
Ma'am, it is in PC, ma'am.
Oh, okay, Amritam. You are listening nowadays. Okay, 16 is present. Sorry, ma. 16 is present. Register number 17 absent. Why he had taken this much of leave, ma? Bibo Anant. 22 Deeparam.
Ma'am, it's working, ma'am.
Yeah, very good. Thank you, ma. Thank you. People kindly attend that. 26 Dinesh Kumar absent. 28 Divagar absent. Any interruption you give me. 35 Hiroki Jodisan absent. 37 Jayashree absent. Sorry, she is present. While I'm taking that, Jayashree is present. 44 Kishan Sango absent. 45 Kotishwari absent. I think Kotishwari having a problem on login. Okay, I will put present for her. 48 Tyagi absent. 49 Vijayshri absent. And 50 Mahalakshmi absent. 52 John Bosco absent. And What happened to Bhanu Prakash? Today I allotted the seminar, so he had taken leave. Bhanu Prakash is absent. So second seminar, definitely you have a privilege on that. Okay. So people are taking, and it will be useful for your assignment, and your knowledge will be also improved somewhat where it is used. 64 Pranjit Das, yeah, absent. 67 Ragul Singh, absent. And the other absentees are Maunika and Vijay Kumar. Sagini Vijay Kumar. Yeah,
Ma'am,
students. Yeah, Anima.
someone enter my register number, ma'am.
Kuma.
73, ma'am.
Yeah, you put 73 along with your name. I will take it like that.
Ma'am, I enter my name only, ma'am.
Okay, Charanya. Hey, why you doing that kind of activities and all, man? You take your own register number and do. Actually, the time is 10:30, and I think it will come till 11 o'clock, ma. I think you please kindly attend the game. I think everyone is playing. Only 19 players are there. See, students, listen, ma. I will cross verify the attendance. Only 19 players. I don't know why. This is to 21 now. Students, please kindly take the quiz. Slowly it is improving. 23 players.